Hello friends, welcome to ESAN Academy. We are into embedded system programming. Okay, discussion on that. We are today with this session. We're going to discuss about C language. This is session 2, and the last class we discussed about declaration, and this class we're going to discuss about assignments. Okay, this these are all C language. So there's a set of rules. So we follow the rules and write a program. That's the thing. So the last session we discussed was about programming. And I say that use very little assignments, only decimal everything. But as much we should know that what C supports. That is a very important for us. Okay. So what is about assignment? It is how are you going to store the values? And it should be very simple for us. Why there's so much of confusion? I mean, why so much of confusion? So in the last session we discussed about CHAR, 8-bit. And then we discussed about short, 16-bit, long, 32-bit, long. Am I right? Now we declare a storage based on this. We say CHAR A, short B, long C, long D. Now when you say CHAR in the memory, you get allocated only 1 byte, 8-bit. Okay. If you say short B, okay, you have been allocated 16 bits. That is A. B, you have 2 lines, 16 bits. If it's a long C, you have been allocated 4 lines. Long means you have been allocated 8 lines. One, two, three, four, 5, 6, 7, 8. 8 lines. 8 into 8 is 64. This is 4, 32. This is 2, 16. This is 1 as 8. Now let us see that when you write a program, how things are stored. That's called assignment. You say now A, carry A. A equal to 25. Now the 25 is getting converted to like this: 1, 2, 4, 8, 16, 32, 64, 128. That's a binary. So 25 means 16 plus 8 plus 1. All the others are zeros. So this 8 bits, this is what your LHS. So your RHS is decimal. This is stored here. It is all very important because we are not doing a computer program. We are doing an embedded system programming. On the hardware, you should know all these things. Okay, when we are discussing this later with the microprocessor, when you combine, you will understand this. You will know the requirement of this. Okay, so this is what we do. So this 8-bit goes there. That's fine. Now, instead of char, if I say short, yay, same thing, I change only short. Now what will happen? This guy will allocate 16 bits. 1, 2, 4, 8, 16, 32, 64, 128. Then 256, 512, 1024, 2048, 4096, 8192, 16, 3, 84. Now this 25 means it gives 1, 0, 0, 1, 1. All the others are zeros. Now, how do I store here? I have two locations. Now, I convert this into two 8 bits. I convert into two 8 bits. Am I right? Yeah, sorry. 256, 512, 1024. Oh, 31 also. 32, 768. Sorry, I missed it. So I have about 8 bits now. Okay. Tell me now, I have 8 plus 8. I have 2 space. Let me write it here. That's easy for you. So I have these 2 spaces here. Now, how do I write? Whether I write this 8-bit in the top, this 8-bit at the bottom, all 0, 0, 0 in the bottom, and all these things here. Okay, I got 2 lines, 32-bit, 16-bit. I have 16-bit, but I can also write like this. I can put all zeros here, and I mean, like, this one is, how do you write this? This one is called, that is, if you write all this, the first one, the top and bottom one here, this is called, this way of writing is called big Indian. And if you do the other way, if you write this number here, and this one here, we call little Indian. That is Indian, where it ends. It's ending at the end one is coming in a little one or big one. That's the thing. Little Indian, not Indian. Okay, don't worry about too much. Now we are doing on Intel machine. Intel machine follow the standard, little Indian. So don't get confused about little Indian or big Indian. So that is, you have 2 possibilities of storing a number. So where do you store? That is, the big one comes in the beginning means big Indian. The small one comes in the beginning means big Indian, little Indian. So we store like this. So if you say short, even though you give a value of 25, I occupy 2 locations. If you say long, then that is 32-bit. So what happened? I store this 4 bits like this. Then think of it long, same thing. So think a trick here. So you may be using a same number, but how it is stored in the memory, different for different declarations. This is fine. They're all fine now. Suppose I want to store 0, 1, 1, 0, 0, 1, 1, 0, 0, 0, 0. This is what I want to store here. How do you store? Initial days, Dennis Ritchie has designed. That time, what he did was, I have to convert this to decimal. I have to convert this to decimal. 1, 2, 4, 8, 16, 32, 64, 128. 64 plus 32 plus 4 plus 2. 96 plus 4, 100, 102. Now I have to write CHAR A equal to 102. So I have to convert it to, suppose if I given you like this, 16-bit number. 4, 8, Okay, 16 bit. 4, correct, 16 bit. Now, how do you do this? Then you have to convert like this: 1, 2, 4, 8, 16, 32, 64, 128, 256, 512, 1024. First of all, you have to write like this: 2048, then 4096, then 8192, then 16, 384, 32, 768. Then you have to add 32, 768 plus 1, 16, 384 plus 4096 plus 2048. Writing itself so much of time for you, 256. So if I give a big numbers, writing this become very difficult. So what Dennis Ritchie did was, hey, don't do it, man. Don't do this. Let us have an easy method. Let us have an easy method. There are two easy methods are there. One easy method is divide this number into a group of threes. Group of threes. So now you see 1017, 0113, 1016. You have to remember only 124, 124, 124, 124. So now I've written 4, 5, 1. See here, it's become very simple. I could be able to convert it. If I have to convert the same thing to decimal, it takes very long time. So converting from a binary of this number. Let us take only 8 digit. Let's take only 8 digit. To converting into the decimal, it's very tough. So what I have done is I put a group of 3. So this is becoming 1, 2, 4, 1, 2, 4, 1, 2. This is how much? 3. This is how much? 6, because 4 plus 2, 2 plus 1, 2 only. I can say A is equal to 263. But if we say A is equal to 263, think of it. I can have maximum is only 255 in decimal. How do I tell the compiler, hey, this is not decimal. This is, I have made it a group of 3. The maximum number here is 0, minimum is 0, maximum is 7. You have 8 numbers. So we call this as a octal. So how do you tell the compiler is octal? So what Dennis Ritchie did, any numbers start with 0. If you put 0, please understand this. This is a very tricky. If I say, I'll write a small program, then you will know the trick here. I'll write a small program, then you will know. I say char, let me share it, sorry. I'll share it. Now you see here, char A, B, C, 3 variable. Am I right? Now let us remove all of them. Now if I say A equal to 100, B equal to 10, C is equal to A plus printf percentage D, comma C. Understand? This is a very simple program. I'm adding 110. Now let's see the result. Let us compile it and see the result. So we got 108. We get 110. We got 108. Why? Because when you say here, there's a trick, small trick you need to understand what exactly happened here. When you say ABC, A equal to 100, since it starts with 1 to 9, the compiler assumes this is a decimal. So what happened? He convert the 100 into 1, 2, 4, 8, 16, 32, 64, 128. 100 means 64 plus 32, 96 plus 4. So this is a number. It has gone here. The A. The A it has gone here is 0, 1, 1, 0, 0, 1, 1, 0. See, that's why I explained to you char itself, easy to do. If you do integer, I have to do 16-bit or 32-bit. So we can do always with char. Now, if I say B equal to 0, 1, 0, there's a problem. This guy converts the thing, start with 0. You start with 0. So what our man did was quite simple. 0 means 0, 0. 1 means 0, 0, 1. 0 means 0, 0, 0. Is actually what? 1, 2, 4, 8 is actually 8. Okay. So he stored here on B 0, 0, 0, 0, 1, 0, 0, 0. This is what's stored. So please understand the compiler. The compiler assumes if you give a number start with 0, then it is called octal. 1 to 9 means decimal. 0 means octal. And I can say B equal to 0x 10 instead of 0, 10. 0x means hexadecimal. That we'll be using quite a lot in our embedded system programming. So better understand as early as possible this. That means that I make the 0 to 4 digit. In octal, I did 3 because 2 power 3 is 8. Now I do 4. 2 power 4 is 16. The 1 I make it as a 0, 0, 0, 1, 0. See here what is stored here. So if I write a program now, if I change the program now, see the result. Our original program, okay, we can see the result now. How this guy is behaving now. Now I make 0x10. Only small change. Instead of 10 0x. Now I run the program. You see that you get the result of 116. Because if you put 0x, so please understand, left hand side is binary, right hand side is anything it can be. That is what all the types of assignments. It could be by decimal, or it could be the right hand side. The right hand side could be decimal. That is example is 100 or 10. You take 10 itself. Or octal. 0, 1, 0. Start with 0 means octal. Hexadecimal. Zero x 1 0. Now third one is there. That I say B equal to within quote 1. Within quote, but single quote. If you put single quote, I can give only 1 digit. That's all to see. Don't ask me why. These are all rules defined by Dennis Ritchie. I am just middleman. I am passing the rules to you. That's all. This is what Dennis. You cannot do like this. If you say that, is no meaning. Of course, he will give different way. Don't worry about that. Let's not worry about if I give this, what will happen. Let us follow the rule. If you put single quote, you can have anything, A, B, any symbol. And yesterday somebody asked me that it's about ASCII. This is called ASCII. Now what happened? There is a table available worldwide. In the table, for every symbol, there's a number. Binary. There's a binary number. So, if I say here 0 symbol, Then I have, if in quote, if I give 0, then the binary is 0, 0, 1, 1, 0, 0. If I give 1, then 0, 0, 1, 1, 0, 0, 0, 1. If I give A, then quote up to 9, A. If you give 0, 1, 0, 0, 0, 0, 0, 1. If you give B, then 0, 1, 0, 0, 0, 1, 0. These are all provided by the ASCII committee. But understand one thing. I may here put A, B, C, D. When it goes here, everything is binary. See, the left-hand side is always binary. The right-hand side could be anything. But once you convert it, nobody knows what was the originally it came. For example, let us see. I will tell you one small program here. Then we will be able to have a good idea. You will get a small confusion now. That idea will be clear now. See here. Sorry. See here. I put here, let us assume the value of 10. And B, within a single quote, I put A. Then I put C is equal to A plus B and put C result. See that. I'm adding a decimal with a symbol. Am I right? We are, for us, it doesn't mean anything. But in computer, in a C language, this is meaningful. See here, what result you get. You'll be very surprised. We will discuss about the result also. You get 75. Now let us discuss about how we got 75. Then you will have a little bit clarity about our understanding. Okay, about this, what do you call? Assignment. All the additions are taking place only with the memory, which is binary, not with you. So if I write a program, see here, if I write a program, CHR ABC, A equal to 10, what is stored in memory is 0, 0, 0, 0, 1, 0, 1, 0. Because it's a 1, 2, 4, 8, 16, 32, 64, 128. 8 plus 4 is 10. Fine. When I say B is equal to within quote A is how much? This is given by the ASCII table. Not you. The compiler will refer the table. There is no logic here. This was given by the committee. So A is 0, 1, 1, 0, 0, 1, 0, 0, and 0, 0, 0, 1. Now, the trick here is when I say A plus B, C is equal to A plus B, we are adding the binary. So 1, 1, 0, 1. That's it. When you say printf percentage D comma C, then what the printf does, he goes and looks a location. Then you put percentage D, means decimal. So he will convert who? The printf. Oh, this is 1, 2, 4, 8, 16, 32, 64, 128. Oh, 64 plus 8, 72 plus 2 plus 1 equal to 75. That's why you got 75. So please understand, whatever may be your right hand side, when it goes to left hand side, all are only binary. Please. So there are 4 possibilities are there. Nowadays, latest all the C languages, even GCC made it as an extension, not fully within the C, but it's everybody start following. Everybody start following. You can now say CHAR A equal to 0B 00101101. The binary, you can write directly binary. This was not possible till few years before. But nowadays it's become very easy because on embedded people, this will be very, very helpful to you. So there are five possibilities. One is start with any number between 1 to 9. That is decimal. Then other one is starting with 0 is octal. Correct. Yeah. A is not 75. A is 65 because A is 0, 1, 0, 0, 0, 0, 0, 1. This is 64 plus 1 is 65. For A, the equivalent decimal is 65, not 75. Got it? Correct. That's what I'm saying. C is not character. That is what I'm telling repeatedly. This is what I'm telling repeatedly. Once again, you have a doubt. You see that? That's what people say when I say CHAR, C, and C is equal to 45, printf. I don't know who told you these things. When I put CHAR, I have to put only percentage C. No, need not be. I can do anything here. I can declare anything. I can print anything, which I'll show you the next class. I'll explain to you in depth, or now itself. I'll explain to you now itself, please. Since you people have asked this, I need to explain this for a minute. This doubt, I will show you one small thing. A minute. We have to clear our doubts. Am I right? Now you see here, I put A is equal to 65. I remove everything. Am I right? I put A is equal to 65. Now I put percentage CA. It's a very simple. I got 65. Am I right? If you put, I'm not changing anything. I'm changing only the C to D to C. I'm changing only the printf. I don't change anything else. See here. I get A. Am I right? Now I change this to X. C41. This is a 41 hexadecimal for the same 65. Okay. Percentage O. One not one. I know they support B. I want to check. I've not checked so long. Let's see whether they implemented. B is not. Sorry, I thought they would have implemented this. Okay, not it. It will come shortly. It's a thing is going on. B means binary. Now you see octal. Now you see that I've seen various types. Understood. I put D. I put C. I put O. I put X. This guy. Now I'll tell you the process. Please, since you asked the very valid question, and this will clear a lot of doubts for people. So what happening is this: when I write a program, CHAR A, I say you have a problem because you see the full code. A is equal to 65. If you put that I'm explaining to you now. I'm explaining to you now. Perfect. You are right. Correct. Yeah. Thanks. You get the thing. Now I say A equal to 65. What is happening is this. I have a location allocated for A. The A is called content. The A is called, I write only one location, the memory. Then easy. The memory, I have only one location, that is A. This is called location of A. Location of A variable. And this is content. Or A, variable A. If you put, for example, here within quote A, now what the compiler does, he goes and checks the A 00101. Then he will replace this with and this will go here. Understand? So what right hand side will be always getting converted to binary and goes there. When you do printf, percentage anything you give, and you give here A, then what the printf does is, since you are given A, it goes to a location of A and take the content. Now he took the content 01000001. Now he got the content. But if you put C here, then the printf will take this and go there and refer the ASCII table. For this it is A. So you will get on the screen A. If you put D, then the printf will calculate 64 plus 1. He will print 65 for percentage C, percentage D. And if you put percentage X, he will calculate the hexadecimal 41. If you put percentage O, he will divide this into 33. 101. That's why you got 101. So please understand, your declaration does not affect your printf. Please. All the three are independent. That compiler will first see this for allocation only. This is not for what type it is. Maybe in later languages, Pythons and C++, they're all complicated, but C does not. C do not have a character type. C have only two types. One is called float, other one is called integer. Only two types. C do not have a character type at all. Please. So whatever you store will be only as a binary in C. This is a very low level language. Very low level, I explained also what is happening. So you give any number, when you print of whatever you are giving here, percentage, that you will print. Okay. Now we'll see one more thing. How this guy stores negative numbers. If I say here, A equal to minus 55. Okay. What this compiler will do, he will take the negative and put 1 here as a sign bit out of 8 bit. You put 1 here. This is a sign bit. That is bit number 7. Now your actual number will go only how many bits? 7 bits. 6, 5, 4, 3, 2, 1, 0. Now 55 will be converted to binary. How much? That is 48, 36, 32 plus 16, 48, 8, no? Am I right? No, 62. 64 is not there. And 32 is there. 16 is there. 8 is not there. 4, 2, 1. 32 plus 16, 48. I converted. This is how many bits? 7 bits. Now, we take these numbers. Let me write it bottom. 1. That is 7th bit. 6, 5, 4, 3, 2, 1, 0. We take the ones complement. That means that 0 will become 1, 1 becomes 0. Then we add 1. It becomes 2's complement. So the number will be, this is what's stored in your memory. Normally we think, most people think the 55 will be converted to 55. We add a sign bit. That we don't do that. We don't do that. That's the way it's not work. It takes big process. It converts into 2's complement, then put 1. This is the way C stores any negative numbers into the thing. So as I told you last class itself, every declaration is having a limitation. CHAR means minus 128 to plus 127. So when you declare character CHAR, don't give anything. If you give minus 129, what will happen? Don't ask me. That's not legal. So he may store anyway. Yeah, you want to have another number? Any number you. I'll explain to you why it is. Let us take a small example. Since he has asked, I'll explain now. Now, if I say, you see here, CHAR A, B, and C. A equal to 4. B equal to minus 4. Okay. C is equal to A plus B. If your method 4 means 0, 0, 0, 7 bits. Okay. And add a sign bit now. No sign bit. Sign bit is 0 because it's positive number. This minus 4, if you put 0, 0, 0, 0, 1, 0, 0, but the sign bit is 1. If you do your method, minus 4, now you add, what do you get? 0 plus 0, 0, 1 plus 0, 1. Then sign bit become 1. Since if you do printf, comma C, what do you get now? Because of 1, you get negative. You get 8. Minus 8. This is wrong. If you add 4 and minus 4, you're supposed to get 0. Now let us see our method. Our method. Now I have taken the number 4. So this is positive. So I didn't do anything. I written directly. And sign bit is 0. Now minus 64. I'll tell you after this. After this, I'll give you about thing. Minus 4. I'll write 4 now. 0, 0, 0, 0, 1, 0, 0. Take the 1's complement. It becomes 1, 1, 1, 1, 0, 1, 1. I add 1 to it. It becomes 0, 0, 1 plus 1, 0, 1, 1 plus 1, 0, 1. Now I put sign bit as a 1 here. Then we add this number. This is what the new number. Now you add it. 0 plus 0, 0. 0 plus 0, 0. 1, 1 plus 1, 0, 0, and 1 here. 1 plus 1, 0, 1 here. 1 plus 1, 0 here, 1. 1 plus 1, 0 here, 1. 1 plus 1, 0 here, 1. 1 plus 1, 0 here, 1 is goes off because I have only 8 bits. So I got 0 now. You understand? That's why we are always using the 2's complement here. Now somebody asked about how do I do minus 64? How do I ask minus 64? Actually, there's nothing called binary subtraction. Actually, it's it's addition. I will give you the number system videos today. Try to understand that. There's nothing called binary subtraction. I'll explain to you now. If there are a thing happening is in decimal. If we put 9 minus 6, it is called 3. But I can do the same thing like addition. 9, what is the 10th complement of 6? 10th complement of 6 is 4. Add of them. 9 plus 4 is 13. Remove the 1. I get 3. This is the way they do the complement. In our decimal, we do 10th complement. In computer, they do the see, please understand, In digital electronics, we will discuss about in this digital electronics. There we have an adder. We have adder. But once you complement, see, you give a number A, you give a number B, you get the added value. But I put the inverter here, full inverter. I get complement. I add the first C in as also 1 here. Then my adder become a subtractor. So please understand, there is nothing called binary subtraction. Please, let me be telling you one thing. Is actually a 2's complement and addition is called binary subtraction. So what you have to know is only adder. So if you, for example, if you say 76 minus 64, what that guy does is, he converts the 76 into binary. He converts the minus 64 into decimal and add it. Okay, so this is called about binary arithmetic. Okay, so if you would like to have it, I'll give some videos for that. So how actually binary subtractions are going on, binary addition. Actually, I've added all these things in a number system video. So don't get confused too much. Please know why I'm telling is this is normally we don't teach these things in C people, but this is very important for us. We do not use nowadays octal. We do not use octal. So don't worry about octal. But we use predominantly decimal when you do C programming. But when you come to the embedded system programming, it is predominantly used by the hexadecimal. You should understand when you put 0x93, it is nothing but 1001 0011. Understood? For example, in hexadecimal, 0 to 9 is same, like a decimal. But 10, 11, 12, 13, 14, 15 is A, B, C, D, E, F, which is not there in a decimal. Decimal is only 0 to 9. In the hexadecimal, I can write like this: 0x EF. E means 14. That is 1110. F means 15. 1111. That's why I requested you to watch the number system videos. You'll be able to understand like this fast. When I write a number tomorrow, let us say when I write a number, we are going to discuss about even 32-bit processor. In 32-bit processor, the data is 0x1 F F E 6238. You get confused, but actually it's nothing but 8 is 100, 3 is 0011, 2 is 0010, 6 is 0110, E is 1110, F is 1111, F is 1111, 1 is 0001. See, 32-bit. How do you write the binary? It's very tough. That's why they're given this. So please understand, if you would like to go in depth to the ARM microprocessor, ARM and DOT 32-bit processor. If you do 8051 or Atmega or PIC and DOT, you will use 8-bit processors. But when you move to ARM, then they will talk about only like this. So please don't hesitate. Watch the video which I have given the number system. If you have a doubt, ask me here. I don't want to spend too much of time on the number system in the class. It's a very simple. Correct. If you add 100 plus 0, 10, it's be like this. If you put A is equal to 100, if you put A is equal to 100, then what is stored in the memory is 0, 1, 1. That is 64 plus 32. 128 is not there. And 16, 80 is not there, 4. 64 plus 32 is 96. Plus 4 is 100. When I put B is equal to 0, 1, 0, I take this 0, I put 0, 0, 0. I take this 1, I put it to 0, 0, 1. For the 0, I put 0, 0. So when I add it, I become 0, 0, 1, 1, 0, 1, 1, 0. Think of it. This is how much? 64 plus 32, 96 plus 8, 104 plus 4, 108. Understand? That's the way. You try to do this. These are all quite simple. Go and watch the video once again. You will be able to understand this very clearly. Because this 0, you have 0 here. That's getting converted. Because it's only 2 bits. That's why they put 0, 0. Because you have 0, 1, 0. See, for example, if you say here, think, you are right. Now, very good. Good question. That if I say A is equal to 1, when I convert it to binary, I put 1 here, all remaining 7 bits, I make it 0. Am I right? The same thing, when I put 0, 1, 0, I put here, for 0, I put 0. For 1, 0, I put here. And left the remaining 2 bits, I filled with zeros. That's the way. That's the way it works. But if we put here 0, 3, 1, 0, we put 0, 3, 1, 0, then 3 becomes 1, 1. 1 becomes 0, 1, then 0, 0. Understand? So this is all about assignment. So please don't, we will discuss about this later, double quote. If I write here 1, 2, 5, then this is called string. That is coming under the later part of it. Right now, we are discussing only decimal and octal, hexadecimal, symbol, and binary. This is start with 0, 1 to 9. This is start with 0. This start with 0x. This start with within single quote. And this start with 0b. That's it. If you know this, forget about this. This we'll discuss later. String is a totally different discussion. That comes in the arrays, string, pointer. The C is actually defined like this, as a binary, as a pyramid. It'll be very nice. It's like this. There are 4 basic functions: declaration, assignments, statement, and control statement. That is if, for, while. Then this is what we discussed the first session. We're discussing this second session. And then we have called arrays, string, pointers. Then we have called structures and unions. Then called preprocessor. This is what the way the C has been generally defined. That's all. No much. If we go through this one, then you can discuss anything with me. I'll be able to make you to understand about C language. But this is not very important. This is knowledge. I'm telling you once again, this is knowledge. All your focus should be on programming. Make sure that you complete 1 set per day to me, 1 set. That's 5 problems. All start with very simple problem. If you sit here, done. You will be able to do it so short. Only problem is you are not sitting. I know that about programming. The only problem is you are not sitting. If you sit, you will do it. You are a wonderful guy. But only problem is this is not called postponing. This is called procrastination. Please do not procrastinate. This is a skill. We lose all the skill just because of procrastinating. So don't procrastinate. Understand? I'm ready to help you to do any level on C programming. Please start. You start. I sent the first set. If you have not got the first set, please let me know, because you may not be stored on my number. That's the ESN Academy number into your this one contact list. Then that way the WhatsApp group may not have sent you the message. Otherwise, you would have got the first set by now. I requested everybody to add this ESN Academy number into your contact list. Okay. That is 90429-14720. Add it onto the contact list. Anything else? Any other doubts on the assignment? This is not all about assignments. Nothing more than that. On the right hand side, left hand side is always binary. LHS is binary, and the RHS is this one. All your decimal or octal or hexadecimal or everything. But different time we use different thing. You will be surprised. When you start doing a programming, you will start doing that. But initially, first 35 problems, you would be using only decimal. Don't worry about that. Once you cross 35 problems, then I'm going to increase it to 40. So if you cross the 40 problems, then you will do very good. First 40 problems. Till the previous year I had 35. Now I plan to increase 5 more problems. So if you do the first 40 problems, you have done very well. Then you will nobody to stop you. Your growth on C programming. The problem is the simple problems. I've seen. I told you now. I've seen anybody who starts. There are people who have never. At least now I'm coming online. Previously I was training people through only email. They never seen my face. Only through email they have learned within a month the entire C programming. Now we have a lot of facilities. We have a WhatsApp, we have a Zoom, and you can have a doubt, you can ask me. Okay, so many advantages are there today. You'd be very surprised. See that I'm getting a call every day. Today I'll show you a thing. I got a call from somebody today. See here. I'll just read the message. If somebody has given a thing today. See, we are looking to hire a people for payment related projects. We need qualified fresher who have gone through your C training program. That's all. Okay. They want to have embedded people. This is actually embedded company. They wanted to have people, but they said that they have gone through your C programming training. That's all. Finish. Fresher they want. Everybody want. That's why I'm repeatedly telling you that do the C programming very well and prove it to me that you do not have to prove it to anybody. Just prove it to me that you are good at C. You tell me, sir, anytime you call me for an interview, I'm ready to available. I will come for an interview. I will have a one-on-one interview. I'll make sure that how you do that, I'll give you a feedback. But please practice. Nothing will beat you.